Hey there, good day. Welcome to our summer coaching series, Solvebeta summer coaching series. And this is for SS1, number base. Number base is a topic you are familiar with. You've done it in GS2, GS3. But SS1 is just an advancement of number word base. Now, um, in your junior secondary school, you did number base, but you were limited to base 10 and base 2. If you remember, in base 10 there are 10 numbers in base 10. 0 1 2 3 4 5 6 7 8 9. These are the numbers in base 10, which denary system, base 10 system is denary system. Every odd number in base 10 is gotten from this number. You might say, what of 10? 10 is 1 and 0, 11 is 1 and 1, 12 is 1 and 2, and so on and so forth. Then you have your binary number system. You have two numbers in base 2, which are 0 and 1. And you learned how to convert from base 2 to base 10 in junior secondary school, base 10 to base 2, and how to add, subtract, multiply numbers in base 2 in junior secondary school. Now, if you've forgotten, you can check my YouTube channel. You see where the same summer coaching series, I think I explained GS3 for GS3. Yeah, you can check for GS3 number base. You see the explanation of addition, everything you need to know on number base. You can check it out there to get yourself up to date. You can do that before watching this video. GS3 number base. Now we'll go to that of SS1. In SS1, it's very, very important that you note this. Very, very, very important that you know this. For example, if you are given this 2077 in base 10, you are asked to convert to base 8. To base what? 8. I'm going to be making parallels between what you did in GS2, GS3, and this. We are converting from base 10 to base 8. Remember that if you were to convert from base 10 to base 2, you divide this number by 2. You divide the number by 2. Then the remainders are what? Used. So if you want to convert from base 10 to base 8, it's the same thing. You take 2077, you divide by the base you are going to 8. You divide by 8. You want to convert from base 10 to base 8. You take 2077, we divide by what? 8. So 20 divided by 8, that's 216, remainder 4. 47 divided by 8, 8 times 5 is 40, remainder 7. 77 divided by 8, 8 times 9 is 72. That's remainder what? 5. So you can see that it's 259 remainder what? 5. Please, or we can just separate this remainder here. Just write as the remainder here. You can separate it. Now let's divide 8. You keep on dividing by 8. 25 divided by 8, that's 3. 24 remainder 1. 19 divided by 8, that should be 2. 16 remainder 3. So let's divide this by 8. 32 divided by, that's 4. 4 remainder what? 0. There's no remainder. So 4 divided by 8 now. You will not stop here when you get this remainder 0. You have to stop when this is 0. 4 divided by 8 is, because 4 is less than 8, you say 0 remainder, this what? 4. So it means that 2077 in base 10, we are going to stop here because we are getting 0, is the same thing as you move upwards. 4035 in base what? 8. 4035 in base what? 8. The same way, if you are converting this to any other base other than 10, if you are converting from base 10 to base, maybe base 3, you divide by 3 till you get this. Let's do that. Let's convert it to base 3. 2077 base 10. Let's convert it to base 3. Let's convert it to base 3 so you see what I'm talking about. It's the same to 2077. Here will be the remainder. Let's divide. You divide it by the base you are going to. 20 divided by 3, that should be 618 remainder 2. 7 divided by 3, 9. 7 divided by 3, that's 2 remainder 1. This will be longer than this, but let's do it for emphasis sake. 6 divided by 3, 2. 9 divided by 3, 3. 2 divided by 3, 0 remainder what? This 2. When the number is less, You say 0 remainder that. So 23 divided by 3 is 7, 21 remainder 2. 20 divided by 3 6, 18 and 20 remainder 2. So 6 divided by 3, this should be 20. 16 divided by 3 5, 15 remainder 1. This should be 8, 24 remainder 1. 8 divided by 3 2 remainder 2, that's 6. Now 2 divided by 3, 2 is less than 3, say 0 remainder, this was 2. So you move up, it means that it is 2 2 1 1 2 2 1 in base 3. In base what? 3. I moved up 2 2 1 1 2 2 1 in base 3. And please take note of this. Take note of this. Take note of this. If you are moving from this to base 3, all the numbers here must be less than 3. Look at all the numbers here, they are less than 8 because we're in base 8. So that's how to move from base 10 to any base. To move from base 10 to any base, you have to divide by that base, then use that thing. Now, what if we are moving to base 10? We are moving from any base to base 10. Look at this. We are moving from any base to base 10. Now look at this. Okay, I think I can rub this off. Okay, I've started recording. Let me rub this off. What we are moving from any base to base 10. Okay, let me take this one. 1 2 6 4 in base 8. Let me use the number 8 to base 10. You can use that number or you write this in words to base 10. So you want to move from base 8 to base 10. It's not difficult. Now you do this 1 2 6 4 0 1 2 3. You number it just like you do if you are going to base 2. 0 1 2 3. So you say 1 times this base 8 raised to power this 3 plus 2 times this base 8 raised to power 2 plus 6 times this base 8 raised to power 1 plus 4 times this base 8 raised to power what? 0. I just had a flashback. I was taught this by, that I remember, I was taught by, in SS1 too, by Mr. Jagodino. I'm giving him a shout out if he ever watches this video. God bless him. I remember very, very, very well. So let's continue. That's the name of my teacher in SS1. Wonderful mathematics teacher. Mathematics, I think he teaches mathematics and physics now. So now let's continue. 1 times 8 times 3. Also shout out to I was taught in GS3, I think GS2. I don't really have so much memory, by Mr. Balogun. Mr. Balogun. His children might be watching this. Taught me. I remember him teaching me from base 2. I think I remember now base 2 to base 10. I remember that. So let me continue before I get nostalgic. You know where knowledge is passed down. That's why it is preserved, because it's passed down from one generation to the other to the next generation. So now let's go on. 8 raised to power 3 is 8 times 8 times 8. That's a big number. 8 times 8 is 64. So you must get your calculator. My calculator is here, but I choose not to use it today. 8 times 4 is 32. 8 times 6, 48, 49, 50, 51. Don't say you're not using your calculator. You can use it. It's not a crime. But don't be dependent on it. 8 times 3 is 512. Plus 2 times 8 times 2. 8 times 2 is 8 times 8. Sorry, 8 square. 8 raised to power 3 is 8 times 8 times 8. 8 square is 8 times 8. Which is 64. Sorry. 8 square is not 8 times 2. Let me correct that. 8 square is not 8 times 2. Rather, 8 square is 8 times 8. 8 raised to power 3 is 8 in 3 places. So, now let's go on. You have 6 times 8 raised to power 1 is ordinary 8. 6 times 8. 4 times 8 raised to power 0 is what? 1. So 1 times 512 is 512. 2 times 64, that's 128. 128. 6 times 8 is 48. 4 times 1 is what? 4. So now let's add all of this together. What do you get? Or I think I will use my calculator. No, let me do it. Using calculator for me is psychological. The moment I begin to use calculator for simple problems like this, I become so dependent that just to add, I'll be looking at the calculator. 8 plus 2 is what? 10. 10 plus 8, 18. 18 plus 4, 22. 4, 5, 6, 7, 8, 9. So this will be 692. By no mistake, it's 692 in base what? 10. So this 692 in base what? 10. 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 Now, you can try that. You can try to convert from base 7 to base 10 or base 3 to base 10. If you are moving from any other base to base 10, this is how you do it. Now, let's look at something new. Something that will be new to you. Something that will be new to what you. Now, we are moving. Look at this. 480. 480 base 12. We want to come back to base 10. You're wondering, you have letters here, yes. You have letters, yes. Very, very important. Those letters, they have their significance. Now, you know we're in base 12. If you write 411, let's say 411, 1012. This number is already looking like something else. It's already, it will lead us somewhere which we don't want to go. That's why we have letters here. This E represents what? 11. E represents what? 11. And T represents what? 10. T represents what? 10. E represents what? 11. In base what? 12. If we were to write 41110 in base 12, it would lead us somewhere else. This 11, 1, they are together. They are a singular number. 10, 10 is a singular number. But if you write them like this, our knowledge of base 10 will make us assume this is 41110. So that's why you have E and T. So don't forget, E represents, I'm going to leave this here, E represents 11, T represents what? 10. So it will be, we can take it like this, 4, 11 in base 12. This is 0, 1, and 2. We're going to take these two together. So you have what? 4 times 12 raised to the power 2. Are you seeing it? Plus 11, take it together. 11 times 12 raised to the power 1 plus 10 times 12 raised to the power 0. So what's 12 raised to the power 2? 144. 4 times 144 plus 11 times 12 raised to the power 1 is 12. Don't forget, anything raised to the power 0 is what? 1. 10 times what? 12. So 4 times 1, this is 5, 4 times 4, 16, 1, 16, 17, 5, 7, 6, plus 11 times 12, 1, 2, 11 times 12 should be 11 times 12, 132. 10 times 12 raised to the power 0, this is 12 times 1. 12 raised to the power 0 is what? 1. So 10 times 1, which is what? 10. So you have what? 576 plus 132 plus 10. 8, 10, 11. Now, look at this. 7 plus 3 plus 1 is 11, right? Write 1, because we are still in base 12. 5 plus 1 plus 2, that's 7, right? So you have 718 in base what? 10. 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 That's how you move from one base to the other. You move from one base to the other. You move from one base to the what? Other. Very easy. That's how you move from one base to the other. Now we still have time. Let me teach you how to add in different bases. Let's take time. Let's see how to add in different bases. Just move from base 12 to base 10. The same way you move from base 12 to base 10, the same way you move from base 2 to base 10, the same way you use from other base to base 10. Or should I give you, let me give you one more example on this. Let me give one more example on this. Okay. You can write this before we go to addition. Let me give one example on this. We're moving to base 10. Convert the following from base okay. Let me take some 127 in base 9 to base 10. 127 base 9 to base 10. Let me add 5 127 in base 9 to base 10. So 5 times, okay, you write 5 127 0 1 2 3. 5 times 9 raised to power 3 plus 1, this 1 times this 9 raised to power 2 plus this 2 times 9 raised to power 1 plus 7 times this 9 raised to power 0. 9 times 9 times 9. 9 raised to power 3 is 9 times 9 times 9. That's 9 times 9, 81. 81 times 9, that should be 729. 729. 5 times 729 plus 1 times 9 times 9 is 81. 2 times 9 times 1 is 9 raised to power 1 is what? 9. 9 raised to power 1 is 9 itself. 7 times 9 raised to power 0 is 1. Oh, this is a big number. Wow. 729 times 5, 45. 10 plus 4, 14. 35, 36. Let me check that again. 45. So you have 3, 6, 4, 5. 3, 6, 4, 5. So you have 3, 6, 4, 5 plus 81 plus 18 plus 7. 3, 6, 4, 5 plus 81 plus 18 plus 7. 7, 5, 6. 6 plus 8 is 14. 14 plus 7. You know what is 14 plus 7 is 23. 6 plus 8, 14. 14, 15. 6, 7. 3, 7. Please 3, 7, 5 or 3. 3, 7, 5 or 3. Barring no error. 3, 7, 5 or 3. 3, 7, 5 what? 3. In base 10. In base what? 10. So the next thing we look at, just like I said, is how to add numbers in different bases together. How to add and subtract numbers in different bases together. How to add and subtract numbers in different bases to what? Together. Add, subtract. We look at add and subtract today. Then in the next class, we'll go to division and multiplication. Then after division and multiplication, we'll now look at some things in base 2 that you were not taught before. Bicimals. We look at bicimals. We look at bicimals. Let me try my best to go through this. Bicimals. That's the next class. So let's look at how do we add and subtract numbers in different bases. Then I give you something to do. Add and subtract, addition and subtraction. Addition and subtraction. So let's add these numbers. Let's add this. Let's look at this example. 314 in base 5 plus 24 in base 5. Please pay attention to this. Very, very important. I want to add this in base 5. It is not the normal base 10. If you recollect, when you were adding in base 2, in junior secondary school 3, you learned something new, which was strange, but it's not strange. Now let's look at it. I want to add in base 5. Remember that every number in base 5, there's no number 5 and above in base 5. The numbers in base 5 are 0, 1, 2. 4 plus 4 is what? 8 in. Normally when you add the 8, but because we're in base 5, 8 divided by 5 is 1 remainder over 3. So you write 3, then this 1, you bring it here. You're writing the remainder, you are carrying this what? 1. You are not carrying the remainder, you are writing the remainder down, and you are carrying this what? 1 here. Please take note of that. You are writing the remainder, and you are carrying what? 1. 1 remainder 3. You write the remainder, and you carry this what? 1. 2 plus 1 plus 1, 4, then 3. So it means that If you add these two numbers in base 5, you get what? 3, 4, what? 3. 3, 4, what? 3. Let's take another example. Let's take subtraction. 5, 1, 1, 7 minus 3, 2, 4 in base. What is the base? Base 8. Base 8. 7 minus 4, it is 3. Now, 1 minus 2, no? We have to borrow from this one. This one becomes 0, we borrow it. Now, once we borrow, we are borrowing 1. When that 1 gets here, it becomes the base here. It is 8. When that 1 gets here, it is what? 8. That one that will be when it comes here, it is not 10. It is what? 8. It is not. It will not be. You will not join it to this one. It will be 8 because we're in base 8. You now add it to this one. 8 plus 1 is 9. 9 minus 2 is what? 7. You add it to this number that is here. The one that we borrowed is 8. When we add it to this one, it becomes 9. 9 minus 2 is what? 7. Did you get that? Did you get that? Did you get that? So what's next? 0 minus 3. We have to borrow from this one. What we borrow from this one is what? 4. That one that we borrow is what? Because we're in base 8, this is 8. Add it to this 0. 8 plus 0 is what? 8. 8 minus 3 is what? 5. Then 4 will come down here. So it is 4, 5, 7, what? 3. Let me look for another example on subtraction. Let me look for another example on subtraction. Let me look for a third example on subtraction. Let me look for a third example on subtraction. Let me come to this place. Let me come to subtraction. So let's say we have 1, 7, 3, 54 in base 9. We want to subtract this in base 9. This addition, this subtraction. We want to subtract this in base 9. 3 minus 4. 3 minus 4, we have to borrow. When we borrow 1 from this one becomes what? 6. Then that one that we borrow, because we're in base 9, it will become what? 9 here. 9, are you seeing it? But there's still 3 here. 9 plus this 3, we add to this one. 9 plus 3 is what? 12. 12 minus 4 is now what? 8. 6 minus 5, 1. This is 180 base what? 9. So we have looked at addition and subtraction. Okay, let's take this. 66. This will be the last one. 66 plus 99 plus 48 in base 12. Base 12. Don't forget, I told you that T means what? 10. YE means what? 11. T means 12 and T means 10. Initially, I said T is 10 in base 12. And I told you why it is written as T. YE is what? 11. Have that at the back of your mind. So let's add 66 plus 99 plus 40 what? 8. 6 plus 9, 15. 15 plus 8, 23. Now 23, we have to convert it to a number in base 12 by dividing by 12. 15 divided by 12, that's 2, 1. Is it 2? 24. No, 1 remainder 11. 1 remainder what? 11. So we write this 11. What's 11? E. Then this one will be carried there. So 1 plus 6, 7. 7 plus T. T is 10, Abi. 7 plus 10, 17. 17 plus 4, 21 again. Yeah, wow. 10 plus 4, 14, 21 again. Oh, it's not 21. It's not again because the first one was 23. 6 plus 1, 7. 7 plus 4, 11. 11 plus 10, 21. Okay. 21 divided by 12 is 1 remainder. What's 1 remainder what? 1 remainder 9. 1 remainder 9. Yeah, 1 remainder 9. Now you write 9. Then you carry what? 1. 1 plus 9 is what? What's 1 plus 9? What's 1 plus 9 is 10, Abi. Instead of writing 10, we use T to represent it. T9 what? E. So it is T9 what? E. For those that we do computer, for those that would offer courses in, maybe you want to be a computer engineer, you need to learn all of this very well. So it is T9E, that is our what? Answer. When we add this together, T9E. T here is 109, E here is what? 11, which is 11, which we call 11 in base 10. E is 11 in base 10, T is sorry, E is 11 in base 10, yeah, T is 10 in base 10. So quickly do this, do this. Quickly, let me write something you should do. Try this. Number one, convert the first one, 1, 2, 3, 9 from base 10 to 8. 2. 1, 3, 3, 7 from base 10 to base 9. Then 3 ET from base 12 to base 10. 3 EET. Okay, I think that should be enough. 3 EET from base 12 to base what? 10. Then the 2, you have to add this. Let's delve into addition. You have to do this. 3, 2, 1 minus 1, 1, 3 in base 5. Base 5 is the first one. The second one, 7, 7, 4 plus 4, 4, 7 plus 1, 1, 3, all in base 8, base 8, base 8. T0E base 12 plus TEE base 12. So do these 6 problems, and if you can solve them very well, you have mastered this topic. So we'll continue in the next class. Bye.